Thanks for coming out today. I'm Jeff from the OpenSSF, and I'm here to talk to you about the AI Cyber Challenge, or as we call it, AIxCC, the results of that, and some follow-on programs we're running now that we've got new open source projects coming out of the competition. So first, just an overview of the competition, if you're not familiar. AIxCC was a 2-year competition that launched at Black Hat and DEF CON in 2023, had semifinals at DEF CON in 2024, and concluded with the finals here at DEF CON just a couple months ago in August. It was set up as a series of challenge projects aimed at having teams and competitors create cyber reasoning systems with the goal of using automation, likely through LLMs, to find and most importantly fix vulnerabilities in open source software. So it took copies of very popular real world open source projects and injected synthetic vulnerabilities into the projects to see if these systems and the competitors could find them and generate patches. Overall, there we go. Had $30 million in prize money associated with it from DARPA and ARPA-H from the US government. And one of the key features was written into the rules, a consideration for accepting any prize money. The competitors had to release their systems as open source software projects. So we now have 7 open source cyber reasoning systems available. And I don't know why it is doing that on me. OpenSSF's role in AIxCC, we were brought in as a challenge advisor. So we collaborated for the 2 years across the competition. Our role was to provide the point of view specifically of open source projects and open source maintainers with an eye towards, I don't know why I'm just doing this, I'm sorry, y'all. To provide that point of view of open source ecosystems and maintainers, because the goal from DARPA and ARPA-H is for this research and the results of this competition to transfer and translate into real world adoption to help us find and fix these vulnerabilities in critical infrastructure. Among our participation as the competition went on, we organized a committee of open source leaders and the maintainers and some key open source projects, advising the creators of the competition on what would be important, what would lead to most adoption, what would projects be looking for to come out of these systems. And now that it's concluded, we remain engaged in kind of the critical phase of this, which is the successful transition to real world adoption. And we'll talk a little bit more about what that is. This here is a view of the actual title slide of the winning announcement at DEF CON. And the interesting part here is patching. That's not the language that DARPA started with when this program came out, but that's really some of the key feedback that we provided and focused on. Is the most important thing is don't give us another set of tools that's going to generate automated lists of thousands of potential bugs and make life harder for maintainers. The most important thing you can do is come with patches in hand to help, for the bugs that have been found, to help fix them and make the maintainers' lives easier. So let's take a just quick recap of how we did. First, looking back, the results of semifinals. So this is a table here with the results from the 7 teams that advanced from the semifinals into the finals round. The green represents a vulnerability that was both found and a patch was successfully generated. The yellow, a vulnerability was found, but a patch wasn't necessarily generated, or if it was generated, it wasn't successful. And as you can see here, there's some success in the C, the project's based in the C language, and not a whole lot with Java. So if we now advance with an extra year to go of developing the competition, expanding the amount of challenges, and most importantly, the competitors having a whole other year to develop these systems further, you see a whole lot more green, lots more success. And just kind of diving into some of these numbers and comparing, In finals, 86% of the synthetic vulnerabilities were successfully discovered, 68% of them were successfully patched. And the average time for patches decreased if we're comparing it to the semifinals, meaning just overall, these systems becoming more and more effective and more efficient. In addition to the synthetic vulnerabilities, these were copies of real projects being scanned, and in the finals competition, the teams found a total of 18 real-world zero-day vulnerabilities and generated 11 successful patches for those. Just diving through some more of the numbers here. For those real-world vulnerabilities, all 7 teams, each of them identified at least one real-world vulnerability. 4 of the teams generated patches that were 1 line long. 3 of them scored on 3 different challenge tasks in a 1-minute span, so some kind of rapid discovery and deployment. And 1 team scored for a patch that was more than 300 lines long. So, overall, these CRSs were challenged in the finals to run across more than 54 million lines of code. And just an interesting key point, in running against that large of a task, the average spend was about $152 per competition task. So if you think about, $152 to find a real world vulnerability and patch it, that's pretty impressive. So now let's talk, when the finals are over, we have these open source systems, what comes next? This is the part we're most excited about. Something we've been very focused on is first impressions are the most important thing. We have these 7 open source projects now, and we got a series of real vulnerabilities to report. We want to make a good first impression with these results and what these systems can do, because we're approaching a landscape that is very skeptical of AI and has been experiencing AI slop. Here's an example, pretty well-known one. Our friend Daniel from curl expressing the concern that many in the open source ecosystem share, right? Anytime new tools come out that are more and more efficient at generating bug reports, that just creates more work for the maintainers, especially if those tools aren't being used responsibly. So our position is, let's put a human in the mix to make this good first impression. So is that human DARPA approaching open source projects saying, hey, I'm from the government and I'm here to help? Maybe that could be successful, but they thought maybe this is a better place for us to come in together with our partners from the Open Source Technology Improvement Fund at OSTIF, so that we can approach the projects and say, hey, we're your friends in the open source ecosystem and we're here to help. So this is the program that is now underway. We're taking the results from these systems. We're taking things that have been found and giving the patches a review. We're engaging with these open source projects as a human, reporting the issues through whatever process that individual project likes to do for its security reporting and patch submission. We're also offering some funding, a small stipend in exchange for that project's time to work with us and review the patches and give us feedback. And we're hoping to build up some success and positive momentum. And this is underway this week. I'm looking at my friend Amir here. How many are we talking with this week, for example?
I know the issues are being analyzed. Running into some issues, we're producing a lot of them. The reach out is happening and get some good momentum.
Yeah, so he's saying, we're analyzing these issues and in the process of outreach, but we're doing exactly that. We want to make sure we can reproduce what the machine says it can produce, right? And reproduce the bug before we go bother the open source project and maintainer. And so if we check back in on our friend Daniel, and we'll be engaging with curl as part of this process, but kind of in parallel with this whole process in recent months, he's been getting some reports. And he published a recent blog post following up on his previous stance about AI that was a little more positive. And the reason why is It's because there's humans using these tools and then engaging with his project as a human to make these reports and submit these patches. And those are being successful. In his quote here, the entire process felt very human, and that's what he's looking for. So that's what we're after. If you'd like to be a part of this in any way, we invite you to join us. We have at OpenSSF an AI/ML security working group, and within that working group, we're hosting a cyber reasoning system special interest group that is basically the post-competition home for collaboration on this. We have the teams participating in with us, as well as some of the competition organizers, and then our membership and end users looking to evolve this process further. So that's where we're at. Thank you all for coming. I don't think we have time for questions, but I'm happy to stick around in the hallway here after if anybody wants to chat further about this. Thank you.